right, it lies in between is a thin transparent membrane fibrous tissue. Diameter. The innermost layer cranial meninges. Innermost layer the cranial meninges, and it is adheres to the surface of the bone, and it firmly adheres to the surface of brain. It is very thin and composed of fibrous tissue. Look at this. Now, this is what about the meninges, mainly the cranial meninges. After that, you see, there is a condition sometimes called, you need to remember this thing, called meningitis. The term used is meningitis. What is meningitis? Can I rub it out, please? Okay. Whenever the term meningitis is used, it is called as inflammation of brain and spinal cord membranes. Inflammation of meninges covering brain and spinal cord. Inflammation of meninges covering brain and spinal cord is called meningitis. It is caused due to viral infection. but some bacterial infection is also found. Suppose meningococcal meningitis is caused by bacterial infection. Mostly it is viral. Sometimes it is due to bacterial or fungal infection. This is what about the meningitis. The symptoms are headache. The common symptom for meningitis is headache, fever, and stiffness of neck. Neck becomes stiff. Now this is what about the meninges. Is it clear? Meninges, trilayered, outermost layer, dura mater. Then you will get the arachnoid mater. Now you see one thing, just below the arachnoid there is a space. Below the arachnoid mater, the space just below the arachnoid mater is called, the space just below the arachnoid mater is called what? The space just below the arachnoid mater is called subarachnoid space. The space below the arachnoid mater is called subarachnoid space. Okay? The space just below the arachnoid mater is called subarachnoid space. And you know, subarachnoid space has its own importance. CSF is found CSF is found in the subarachnoid space. So this is what about the meninges part. Now we are coming to the brain. Can I rub it out, please? Can I rub it out, please?
Yes, sir.
Okay. Now brain. Now you see, in the brain you will get, it appears like this. This part is the midbrain. The forebrain. Cerebellum. Pons. Medulla oblongata. So you see, here it is called the corpus callosum. It's called the cerebral hemisphere. And below which you will get the thalamus here. Now, if you go to the another diagram, just a minute. Hello. আচ্ছা আচ্ছা হ্যাঁ হ্যাঁ কল আমি এখন তো ক্লাসে আছি আপনি আপনি যদি সেন্টারে আইন সেন্টারে বিকেলে আইন তাহলে আজকে এখন আমি ক্লাসে আসলে আমি একটু ক্লাসে আছি এই যে আমার সব কথা কমই উপায় নেই আর কি। হ্যাঁ, আপনি বিকালে এলে এটা কি একটা মিনিট থাম, একটা মিনিট। Look, here, these are the gyri. These are the convolutions found in the structure of brain called gyri, and they are called sulci. Here, corpus callosum. Lateral ventricle. Third ventricle. Aqueduct of Sylvius. Fourth ventricle. Now, first of all, we need to classify brain. What is found in the brain? Forebrain, midbrain, hindbrain. Forebrain, midbrain, or hindbrain. Forebrain includes for the parts found in the forebrain, most importantly, telencephalon, and diencephalon. Telencephalon, important part is cerebrum. The important part of the telencephalon is cerebrum. So I'm showing you cerebrum, and diencephalon includes thalamus, hypothalamus, epithalamus, metathalamus. Telencephalon includes cerebrum, diencephalon includes thalamus, hypothalamus, epithalamus, and metathalamus. Clear? Now, this is the cerebrum. Midbrain includes tectum and cerebral peduncle. And hindbrain includes pons, cerebellum, pons, medulla oblongata. So these are the main parts. As you see, they are the main parts of the brain. Not actually, you can say in it Clear?
স্যার নিচের জায়গাটা
আচ্ছা না সেটা কমপ্লিট কর। Is it okay? Now, one by one coming to this. First of all, we have to consider the ventricles of brains. Ventricles of brain. Ventricles of brain include first of all, you know, right and left lateral ventricles. Or to right. Is it okay? Completed? Copy it. Is it copied already? Is it clear?
Yes, sir.
Okay. Now, what thing is actually, you know, there are two cerebral hemispheres coming to this. First of all, I have to discuss the brain ventricles. So I have to wrap the lower part only. Lower part completed, the classification of brain, the forebrain, midbrain, and hindbrain. Forebrain, telencephalon, the diencephalon. Midbrain includes tectum and cerebral peduncle. Completed this part?
Yes, sir.
Okay. First of all, the ventricles of brain. Ventricles of brain includes, first one, right and left. Right and left lateral ventricles. Located just below the corpus callosum. Located just below the corpus callosum. Two ventricles are separated by a a thin membrane called septum lucidum. they with the third ventricle with the help of an aperture by interventricular foramina, called interventricular foramina. This is what about the right and left lateral ventricles. Clear? Look, this is the right and left. This is called the septum lucidum. Here you will get the corpus callosum. This aperture is called interventricular foramina, located just below the corpus callosum. Corpus callosum, what is corpus callosum actually? Corpus callosum is a thick band of nerve fiber, separating two cerebral hemispheres. Are you getting me? Corpus callosum is a thick band of nerve fiber separating two cerebral hemispheres. And just below the corpus callosum, you will get the two lateral ventricles. And these two lateral ventricles are right and left, and they are separated by septum lucidum, and it is connected to the, or it communicates with the third ventricle with the help of by interventricular foramina. What is this interventricular foramina? You will get this is the interventricular foramina. This is the septum lucidum. Is it clear now? Is it okay? Now the third ventricle. So how should I write third ventricle? This right, this celebrating the third ventricle. The third ventricle. This is the third ventricle. So what about the third ventricle? Located below the of brain and located below the lateral ventricles of brain and between the two parts of brain thalamus. That means here you will get the thalamus. This side also you will get the between two parts of thalamus. Are you getting me? Now, the third ventricle communicates with the fourth ventricle by a canal. Third ventricle by a canal called aqueduct of Sylvius, or sometimes it is also called cerebral aqueduct or aqueduct. That means this one, this duct. Is it clear to this? Now regarding the fourth ventricle, fourth ventricle located or situated below and also behind the third ventricle of brain, situated below and behind the third ventricle of brain, situated below and behind the third ventricle of brain. Now what happens here? So what is the most important thing about this? It is continuous with the central canal. Remember this thing? Of the spinal cord. Of the spinal cord. Is it clear up to this? Next most important thing, is it clear up to this? Is it clear? Is it clear up to this?
Yes, sir, clear.
Okay. Now, after that, the third ventricle, fourth ventricle again communicates with the subarachnoid space, that is the space which is found below the arachnoid matter. With the second layer of the meninges. So what happens here? Fourth ventricle, you have to write. Fourth ventricle, writing here. Fourth ventricle communicates with the subarachnoid space. Subarachnoid space. Fourth ventricle communicates with the subarachnoid space. What this space is found, in the meninges by in its roof. Through this foramina, actually, the CSF is drained into the subarachnoid space. Two lateral foramina and one median foramina found. Are you getting me? Three foramina, actually three apertures are there by which the fourth ventricle can communicate with the subarachnoid space. Two lateral foramina and one median foramina eventually communicate with the subarachnoid space. CSF enters the subarachnoid space through this foramina. Remember this thing. CSF enters the subarachnoid space through these openings. Through the CSF enter the subarachnoid space through these openings. And through the open distal end of the central canal of spinal cord. Now, whether all four ventricles of brain completed, is it clear to you? I am just summing it up slowly. Two lateral ventricles are found just below the corpus callosum, separated by a thin membrane called septum lucidum. These two lateral ventricles open or communicate with the third ventricle with the help of an aperture called interventricular foramina. Third ventricle is the next brain ventricle, on both sides of which you will get the thalamus. Third ventricle communicates with the fourth ventricle with the help of aqueduct of Sylvius, or sometimes it is called cerebral aqueduct. Fourth ventricle, is actually, it is found below and behind the third ventricle. And fourth ventricle, from fourth ventricle, the CSF is carried to the subarachnoid space through some specific apertures or openings. And so CSF, you can say, carried to the subarachnoid space from both these openings and also from the central canal. So this is what, in short, about the four brain ventricles. Clear? Is it clear to you? Can I wrap the whole?
Yes, sir.
So I am wrapping out this, okay? So I am wrapping out these writings actually. Diagrams will be there. Did you write this? The fourth ventricle communicates with the subarachnoid space by foramina in its roof. CSF enters the subarachnoid space through these openings and through the open distal end of the central canal of spinal cord. Is it written already? Is it completed, please?
Yes, sir.
Okay, thank you. Then comes to cerebrospinal fluid or CSF. Cerebral fluid is actually secreted from into each ventricle of brain by remember these things. into each ventricle of brain by choroid plexus. Now, from the roof of fourth ventricle, CSF flows into subarachnoid space CSF is actually secreted continuously. Now, from the roof of the fourth ventricle, CSF flows into the subarachnoid space and completely surround the brain. Now you see how much CSF is secreted. Actually, it is about 0.5 ml per minute. Zero 0.5 ml per minute. And that is 750 ml per day. But you will never get 750 ml CSF here. So amount of CSF present is constant 150 ml. The volume of CSF remains fairly constant at about 150 ml. Remember these things. Now, the function of CSF. Functions of it supports and protects the brain. First most important, spinal cord by maintaining uniform pressure. So it supports and protects the brain and spinal cord by maintaining uniform pressure. By maintaining uniform pressure. Next one, it acts as most important, it acts as shock absorber. That is acting as a cushion between brain and the skull. Cushion brain and skull. It keeps the brain and spinal cord moist. And there may be exchange of nutrients and waste matters between CSF and interstitial fluid of brain. Interstitial fluid of brain. So this is the basic function actually. Most important thing, it acts as shock absorber. It acts as a cushion between brain and spinal cord. Obviously, it is protecting by maintaining uniform pressure also. And also helps in the exchange of nutrients and waste products between CSF and that of interstitial fluid of the brain. Is it clear now up to this? Is it clear? Is it clear to everybody at least what is CSF? From where CSF is secreted? What is the constant volume of CSF and its role? Clear? Where is CSF found?
Yes, sir.
Okay. After that, so this part is completed. Now we have to proceed towards the cerebrum.
So whatever written after exchange of nutrients,
Yes.
after exchange of nutrients and
Waste matters or waste products.
okay,
Waste products between CSF and interstitial fluid of brain. Between CSF and interstitial fluid of brain. Clear? Is it clear now? Is it okay? Now in the cerebrum, we have to start with the cerebrum now. Solve it out. This part is the cerebrum actually. Now if you go to the cerebrum, in the cerebrum, the largest part of brain. Cerebrum is the largest part of brain. And you see here what it is found. There are two hemispheres found separated by two cerebral hemispheres are connected by called corpus callosum. Two cerebral hemispheres are actually connected by, so that to one cerebral hemisphere, the other cerebral hemisphere connected by corpus callosum. This reddish one is the corpus callosum, and what it is found, what it is the role of this corpus callosum also to connect, so that it can tell one hemisphere what is going on in the other hemisphere. I'm telling you, it can tell one hemisphere what it is going on in the other hemisphere. This is the role of corpus callosum. Is a thick band or nerve fiber separating or connecting two cerebral hemispheres. Okay. Now go through each cerebral hemisphere. You see what is found. The cerebral hemisphere shows a number of infoldings. Cerebral hemisphere shows many infoldings. So many infoldings or furrows. Shows many infoldings and furrows of varying depth. These folds, suppose these are the folds, you see, or convolutions. So this is the furrow. This is the furrow. These folds are called gyri. These folds are called gyri. And gyri are separated by, gyri are by fissures called sulci. So, you know, the cerebellum has a number of infoldings. So these folds are called the gyri, and the furrows or the fissures separating these fissures separating these gyri are called the sulci. So due to the presence of sulci and gyri, you know, so these convolutions increase the surface area of the cerebrum. These convolutions increase the look one thing. I am telling you again, cerebral hemisphere show many infoldings, already shown here many infoldings. And these infoldings, these folds are called the gyri, and folds are separated by some deep fissures. These fissures are called sulci. So in the cerebrum, we get both sulci and gyri, and these convolutions help to increase the surface area of brain. Basically, the surface area of brain is more than that of the inner cranial surface of the inner cranium, Hence, brain is required to be enfolded so that it can be accommodated inside this cranium. Are you getting me? So that it can be accommodated inside this cranium. That's why such folds are developed. If the number of sulci and gyri is more, means the surface area is more. If surface area is more, means there will be more what it is called perception, more communication. Basically, you can say the person is said to be more intelligent. That means there is more sulci and gyri. That means there is surface area is more. Surface area is more neurons can be accommodated. As more neurons are accommodated, so they help in more clarity and perceptions. So the degree of intelligence is found to be more. So it is said, if sulci and gyri are found to be more in any brain, the person is said to be more intelligent. So this is what about the sulci and gyri found in the cerebral cortex. As you know how these gyri develop, as brain is shows a number of convolutions or enfoldings or furrows of varying depth. Okay, and these folds are called the gyri, and the folds are separated by some fissures called the sulci. These enfoldings actually or convolutions help to increase the surface area of the brain. So this is what about this part completed. Now, as you know, in the cerebral cortex, basically cerebrum, you can divide cerebrum into two parts. Cerebral cortex, cerebral medulla. Cerebral cortex is made of, you can call it gray matter. And cerebral medulla is made of white matter. Gray matter is made of actually cell bodies of the neuron, and white matter is made of myelinated nerve fibers. So in the brain, gray matter is found in the periphery and white matter is found towards the center. But in the spinal cord, the location is just reverse. In spinal cord, gray matter is found in the center and white matter is found in the periphery. I'm repeating it again. Gray matter consists of, what is gray matter? The cell bodies of neuron form the gray matter, and myelinated nerve fibers of neuron forming the white matter. Are you getting me? Is it clear to you? Is it clear to this? Cerebral cortex actually consists of gray matters and cerebral cortex consists of white matter. Gray matter actually, cell bodies of neuron form the gray matter. And myelinated nerve fiber from the white matter. In brain, gray matter is located in the periphery. Write it down. In brain, and white matter is in the center. Learn these things. In the brain, gray matter is found in the periphery and white matter is in the center. In the spinal cord, gray matter is in the center and white matter is in the periphery. Can you remember this thing? Is it clear to you?
Yes, sir.
Okay. Now, remember this thing. In the cerebrum, basically, if you know what I said, cerebral cortex consists of gray matter. Cerebral cortex possesses the sensory areas, motor areas, and also the association areas. Just a minute. Hello. হ্যাঁ আসো দাঁড়াও এই তুমি কখন আসছো হ্যাঁ ওখানে হ্যাঁ 10 মিনিট কুইক So you see, where is the so in the cerebral cortex, you know, you'll get the sensory areas, the motor areas, and the association areas. And the association areas is mean for intersensory association, memory, and communication. Responsible for complex functions like intersensory associations. 2. Point 2, memory. Point 3, communication. Intersensory association, memory, and communication. Is it clear to you? Is it clear? Now I am to discuss details about it. But what is it then, and what is the role of sensory area, what is the role of motor area, and how these are actually, and then obviously the different lobes of the cerebral cortex like frontal lobe, parietal lobe, temporal lobe, occipital lobe in my next class. Okay, thank you very much. What is it? In the next class, whether online or offline? What do you want, online or offline? Next class? Anyone tell me? Next Thursday, online or Pitavani. Okay. So that's all for today. Thank you very much.